Today we will go over section 4.3, which is vertical and horizontal asymptotes. In this section, we will go over how to actually find horizontal and vertical asymptotes. Starting from vertical asymptotes, if you have a function that is in rational form, such as fx equaling to px over qx, if your qc equals to 0, right, and if you plug in the constant into your denominator and that equals to 0, then your denominator would be undefined. Your denominator being undefined will give you the vertical asymptote, indicating at that point C you have a vertical asymptote. However, remember your numerator cannot be equaling to 0. So an example to start out would be this: determine any vertical asymptotes of the function given and describe the behavior of the graph of the function for the values of x near the asymptotes. So in order to determine the vertical asymptote, I know my qx, which is in the denominator, should be 0. So I'm going to take whatever is in the denominator, which is x squared plus x minus 2, and equal that to 0 to find my x values. I know if I if I simplify this, I'm going to get x plus 2, x minus 1 equaling to 0. Now that I have my two parts, I'm going to separate these to x plus 2 equaling to 0, as well as x minus 1 equaling to 0. Sending that 2 to the other side as negative will give me the value of x equaling to negative 2, and sending that 1 would give me the value of positive 1. After I have my points, the next thing I do is to make sure my PC, meaning whatever is in the numerator, is not 0. So just plug that negative 2 into the original function, right? And I would get negative 2 over 4 negative 2 minus 2. So that would give me negative 2 over a number. So 4 minus 4 will just give me 0. But I know my numerator is not 0. So negative 2 counts. Negative 2 is definitely one of my points. So now I'm going to check for 1. If you do the same for 1, I know the denominator will be 0 anyways, and I know it's only x on top, so it's 1, so it doesn't equal to 0. So I just checked, I made sure, I verified that it doesn't equal to 0. Now that I have my vertical asymptotes, which occur at these points, the next thing it's asking me is to describe the behavior of the graph of the function for the values I attained near the asymptote. So if I were to draw this, I can represent my vertical asymptotes by drawing dotted line. And in order to describe the behavior, I'm going to make a table. So this table I divided into 4. So I need to find what happens when I approach my vertical asymptote from the left side and from the right side. So this ties back into limits a little bit. So if you remember what coming from the left side and right side means, good. And I also said the same thing for the other vertical asymptote point I have, which is 1. What I'm going to do is plug these values back into my function to figure out what my function will be approaching to when I come from the left side or right side, so I can draw on the graph. Starting from the first one, I know coming from the left side, the very first one, coming from the left side indicates any value that is smaller than negative 2, right? So you can literally pick anything you want. Let's say I picked negative 3 and plugged it back into my function. I just need the sign. So you don't have to deal with, oh, what if I choose a really big number or I have that. Just put the signs up. So I know because I put negative 5, it's going to give me negative for the numerator. Over here, I'll have negative squared, which will give me positive, plus a negative, and then negative 2. Over here, I'll have something positive, and then over here, I'll have something negative and a negative again. So negative times negative will give me positive. So technically, I will have negative over positive. but this as an answer will give me a negative value. Therefore, my function's value would be smaller than 0, indicating a negative value. Then what would my function be approaching to? Since it's a negative sign, it will approach to a negative infinity. So how would I put that onto the graph? Since it's coming from this side and approaching to the vertical asymptote, I know that it will approach to negative infinity. Since negative infinity is at that point where the arrow is pointing, it would be something like this. So getting really close but approaching there. So I will erase these. Now passing on to the second one where it's approaching from the positive side, I can literally put anything over here. So I'll just put 0. Not 0, -1. So if I were to put -1, because I cannot put 0, my numerator cannot be 0. If I put -1, I will get negative up here. And previously, what we did over here, if it makes it easier for you guys, we found that when we simplified that section is x plus 2 and x minus 1. So you can literally put negative over here to get a, if I put -1, I'll get a positive value over here. And if I put -1 over here, it would be -2, right? So negative times positive will just give me negative. And I have negative on top too, so negative over negative will give me positive. So over here, actually, I have bigger than 0. Since it's positive, it's approaching to positive infinity. Coming from the right side over here and approaching to -2 will give me a function that looks like this. I do the same exact thing for approaching from the left side to the 1. For that, I'll plug in 1/2. So if I were to plug in 1/2, I know my numerator will just be positive. I know my denominator equals to this, so I know this section, if I plug in 1/2, that would be positive. This section will be negative. I know positive times negative will just give me negative. Positive divided by negative will just give me negative. So as a result, this is in fact smaller than 0 and will approach to negative infinity. So I know that it is the exact same thing as we did to -2. So it will be approaching from the left side and will be going into negative infinity. Now I try for coming from the right side. Let's plug in 2, which is easier. So if I plug in 2, this section will be positive, right? If I plug in 2, this section would be positive, and this section would be positive. Positive divided by positive will just give me positive, so therefore this is bigger than 0 and approaching to positive infinity. And as a result, when I'm coming from the right side out, my arrow will be going into positive infinity. So from what I have, all I can draw as a behavior of the graph would be this. We can also define vertical asymptotes from limits, which we did in the previous question with the behavior of the function. So if when approaching to constant c from left, here I get the solution positive infinity, or I will get the solution of negative infinity. I have a vertical asymptote at x equals c. Okay, so when drawing it, it would be looking for like something like this, which we did before. Same thing when my x approaches to the constant c from the right, and I get the same solutions of positive infinity or negative infinity. And from there, it looks like these. So if it were to coming from the right side to approaching to negative infinity and approaching to positive infinity and stuff like that, like we did in the previous question. Passing on to horizontal asymptotes. It's a little different than identifying vertical asymptotes. What I'm going to do for horizontal though is to start directly from a problem, as I think that is like the best way to understand this concept. What's putting up here in the box is just a reminder that when we have our limits, which we learned from way before, and you have the value, the x value in your denominator, and x approaches to negative or positive infinity, my solution will be 0. Because if you think about it, as your denominator gets big, the solution gets smaller, such as 1 over 4 equaling to 0.25, right? Versus 1 over 10,000, right? And that would equal to like 0.0001. So if we put infinity, that is just a number that is really close to 0. The second box basically talks about how to find the horizontal asymptote, which I'll show you in the next slide. All we do is take the limits for x approaching to positive infinity as well as negative. If you get the same solution L, that's our horizontal asymptote. So for this question, we'll try to find its horizontal asymptote. So my normal function without the limit is gx, let's say, equaling to x over x squared plus 1, right? From here, what I can do before applying limit is I see that I can simplify this further. So I'll do that by first factoring out the x. So if I factor out x from the numerator, it will just only be 1 left inside, so it doesn't really matter. But if I factor x squared out of the denominator, I'll get x squared, and then inside I will have 1 left for this, because it's, think of it as when I take out x squared, you divide x squared by x squared, so you have 1 left, plus, since I divide by x squared, I will have over here 1 over x squared. Okay. From here, I can see that I can actually cancel out the x's. So I have 1x over here, which I can cancel out, and I can cancel out 1 of the x's from here. So my gx would be 1 over x, 1 plus 1 over x squared. Now that I have the function, I'm going to apply the limits into my function. When I apply to limit, I also apply the limit x approaching negative infinity to my whole function. And I'll use the limit property of distributing it to everywhere. My 1 stays because it's a constant, so I'll distribute the limit into x. And I'll also distribute the other limit as a multiplication to the brackets 1 plus 1 over x squared. First thing I realize is what I mentioned before. Over here, me applying negative infinity into the denominator will just give me 0. So what we do whenever we distribute this limit of infinity, I cancel out anything in this form because it's just 0. Okay, so we first start with that. So what I have left is 1 over limit x approaching to negative infinity x, and over here, since I applied this, 1 is just going to stay, so it's basically times 1. From here, I can just say limit as x approaching to negative infinity will be 1 over x. And from here, I know when I apply negative infinity, just like I did over here, I will get a value of 0. So my answer would be 0. I have a horizontal asymptote at 0. Whenever we are finding the horizontal asymptote, what we do is first try to factor it, simplify it. The second, what you do is distribute the limit to each of them. And whenever you see something in this form, you just cancel out. We are trying to get things in this form so we can cancel it out. That's why I factored x over here. So there's also a shortcut to determine the horizontal asymptote that exists. If your degree in the numerator equals to the degree of the denominator for the biggest power, meaning my degree over here is x to the power of 1 and x to the power of 1, so they match each other, you disregard the rest meaning whatever is after that, and only take the constant in front of these degrees, which in this case would be 2, and in front of this is 1. So 2 over 1, which will give me a value of 2. And actually that would be my answer if I do it the same way I did in the previous question. So you can also solve this just the limit way and end up with the same thing. But this only works if your degrees are the same and your degree in the function has to be like the biggest power. Another example to get used to it would be this one. So over here I see the degree is in this case x squared, and I see that over here I also have x squared. I don't count these. Biggest degree, okay? So biggest degrees, they equal to each other. What I do, I disregard whatever is rest over here and I look at the constants, whatever is given. The constant I have is 2/3. That's my answer. So it wants us to determine the equations of any horizontal asymptotes of the function given, state whether the graph approaches the asymptote from above or below. So the first thing I do, because it's asking for horizontal asymptote, is to find the horizontal asymptote of this. What I realize is, I told you guys before, if the degrees are the same, the first thing you need to check is the degrees. If it's the same, it's just way easier than what we need to do. Degrees are the same for the numerator and denominator that I see. I disregard the rest. I don't care about the rest, and I look at the constants for both numerator and denominator. I have 3/2, so that is my horizontal asymptote. So I have a horizontal asymptote at 3/2. Now it wants us to state whether the graph approaches the asymptote from above or below. So how do we do that? So I drew a graph with the horizontal asymptote. Now, to determine if it's approaching from above or below, what we do is we consider a very large positive and very large negative value for x. So let's say my very large positive value is 1000, right? What I do is I get that 1000 and plug it back into my function. So I would get 3000 plus 5 all over 2000 minus 1, which would give me 3005 and 1999. So from here, I see that my value is bigger than my horizontal asymptote value. Then I can say that it's approaching from the above. Since I chose the positive one, it will go to the positive side and it will approach from the above. So that would give me something like it approaching from the above and going to the positive side, right? Same thing I do for negative. Choose a very large negative value. I'll do the same, negative 1000, which will give me, for negative 1000 now, I'll get negative 3000 plus 5 all over negative 2000 minus 1, which would give me negative 2995 all over negative 2001, right? And from here I see that my value would be smaller than 3/2. Now, because it's smaller, then that means to the graph it's approaching from below. So when it's going into the negative side, it will approach from the below instead of above. So it won't go like this, because that's approaching from above, and this would be approaching from below. So something like that. So this summarizes what we did previously in the question to determine if the graph is approaching from below or above. Like I said, if your function is bigger than my horizontal asymptote, then it's approaching from above. If my function is less than the value of the horizontal asymptote, then it approaches from below. Now, in addition to vertical and horizontal asymptotes, we also have something we call oblique asymptote. They occur when the degree of the numerator is bigger than the degree of the denominator, such as if you had x to the power of 6 over x to the power of 2. The numerator is bigger. When this occurs, we get a straight line that is slanted and the curves of the function comes really close to it. So let's solve one example on this and how to find the oblique asymptote. Find constants a and b such that the graph of the function defined by this given function we'll have a vertical asymptote at x equals 5 and a horizontal asymptote at y equals -3. So starting from what's given to me, I know the vertical asymptote is at x equals 5 and I have a horizontal asymptote given to me, right? And I also have my function. All I need to do is find constants a and b. From here, I know that vertical asymptote occurs when my denominator equals 0. So from here, all I'm going to do is plug in x for the value, x over here. So I have 3 minus b, and my x is 5, and this will equal to 0. Send that 3 to the other side, I will end up with -5b equaling to -3. Divide each side by -5, we will end up with a value of 3 over 5 for b. As for the horizontal asymptote, what I'm going to do first is plug in that 3 over 5 and rewrite the function given to me. So I know my fx will equal to ax plus 5 all over, I'm going to bring that bx to the front, so I'm just going to say -3 over 5x and then plus 3. So now that I have everything, I realize that the numerator degree and the denominator degree is the same, x to the power of 1. This is exactly the same thing we did before. I used the shortcut method and only count the constants. Right now what I have as a constant is a over -3 over 5, and I know this value needs to equal to the value given to me, which is -3. Now, dividing a by -3 over 5 is the same thing as flipping it and multiplying it. So then I have the value of -5a over 3 equaling to -3. Now I'm going to multiply each side by -3 to get rid of this. So I'm going to also multiply this by -3. Let's move up to here. So now I have -5a equaling to 9. From here, I'm going to divide each side by -5 to get a value of 9 over 5. When I multiply -3 over here to cancel, this negative was also cancelled, so it's not negative. So positive 9 over 5. If you have a problem that you would like us to solve, you can always send it to our website in the forum section and we will solve it for you.